Hey folks, in this video we're going to talk about Ohm's law. For some of you this is review, for others this may be new. So here's the idea, all right? Let's say that you have a battery, okay? So there's your battery. And let's say that you hook this up with some wire to a resistor. So there's your resistor and here's the wire, okay? So this would be a picture of the situation, all right? Battery looks like this, like a C or D battery. It looks like that, or one of your double or triple A's in your calculator. And the resistor looks more or less like a round cylinder. And if you actually were to see a resistor, like if you were to tear apart virtually any electronic device, calculator, cell phone, computer, etc., you would see resistors. And they look like this when you look inside. These are 6 different resistors. The colors tell you the resistance, and there's a long story behind that, which we won't get into in this video. But the colors, there's a color coding system that tells you the resistance. Now, that's a picture. What we're going to do is we're going to draw a circuit diagram. Okay, so the symbol for a battery is this. It's a series of parallel lines. The bigger one means positive, and the shorter one, that's negative. So like in this battery, there's your negative, there's your positive. This is what we call the schematic symbol for a battery. And then your resistor, the symbol is basically a squiggly, which kind of looks like it'd be hard to walk through, right? So that's the symbol for resistance, and then wires are still just lines like so. So that would be a schematic, a circuit diagram, which we're going to pretty much, that's what we're going to draw from here on out, are circuit diagrams. If you look at any textbook or any electrical schematic at all, anything, you're going to see these things, okay? Now, this is a resistance and this is a voltage, okay? Voltage. So let's say your voltage is 12 volts, like a car battery, and let's say your resistance is 6 ohms, okay? Current's going to flow. Now, we are going to, from here on in, deal with conventional current. We're going to pretend that positive charges flow. Now, we know better. We know a real current is electrons flowing, but we're going to pretend it's positive flowing. So what will happen is positive charge will flow clockwise through your circuit, okay, like so. So you can kind of think of it as coming out the positive side of the battery, goes into negative. Now, again, they're not coming from the battery. The charges are already in the circuit. The battery just makes them flow, okay? So in this case, positives will flow like so, okay? Clockwise around your circuit. Now, how much charge will flow? What will the current be? Now we know that current is the rate at which charge flows. But how do I figure that out if I have voltage and resistance? Okay. Well, before we give you the equation for this, let's talk about an analogy. You can think of voltage as like electrical height. Okay, so think of voltage as height, all right? Think of a battery as like a chairlift in a ski resort. The battery gives the people potential energy. Okay, well, a chairlift in a ski resort gives people potential energy, does work on people and gives them potential energy. That is exactly what a battery does. A battery does work on charges and gives them potential energy. Now let's go back to the skiers. So the skiers get lifted up the chairlift and then they go to a run and they ski down the run. And all of their gravitational potential energy, at first it turns into kinetic energy, but then eventually that turns into heat through friction. Eventually they stop back at the bottom of the chairlift. So all of the potential energy that the skiers had turns into thermal energy, heat. Well, that's exactly what happens with charges in the circuit. All the potential energy the charges have, when they go through the resistor, that energy turns into heat and it's lost. And then they get again, we're pretending positive charges. The positive charges get back to the bottom of the battery. The battery then lifts them up again to the height, and they repeat the process over and over. Just like skiers on a ski slope. Go up the chairlift numerous times, they ski back down numerous times, and they get recycled. skiers getting recycled on a ski slope is the same thing as charges getting recycled in a circuit. It works the same exact way. Now, how many skiers will flow? All right. So it turns out that the current flowing, the equation to figure that out is very, very simple. The current that flows through the circuit is equal to the change in voltage of the circuit divided by the resistance of the circuit. The more height you give them, the quicker they'll flow. It's a way to think of it. And the more resistance you throw in the way, the fewer of them will flow. Okay. Now, in our example here, let's say the voltage were 12 volts and the resistance were 6 ohms. Well, then you'd have 2 amps of current flowing. So by the way, when you use Ohm's law, current must be in amps, voltage must be in volts, or electric potential must be in volts, and resistance must be in ohms. So it turns out that an amp is equivalent to a volt per ohm. Okay. Now, most of the time when you see this, they're going to solve for V. So you'll see it written this way. The delta for the V is implied, but it's the same equation, just rearranged for V. For future reference, we're going to talk more and more about circuits, and we're going to make the circuits more complicated. Okay. But if you remember that voltage is like electrical height, the charges are like the skiers, and resistance is like the runs that you put in the ski slope. You know, what kind of runs are they? How hard are they? It's a perfect analogy. And so I want you to picture in your mind skiers flowing through a circuit like so. And if you picture that, all these equations we're going to come up in the next little bit, they're going to make a lot more sense to you. All right, so I hope that video was helpful, and thank you very much.